Um, Hello, this is Poonam Shukla. You are 140 CS028, and this is my fourth Unix and Linux lab experiment. And this is here we have to do conversions, basic conversion using shell scripting. So here we have to do binary to decimal conversion, binary to octal, and all everything. So our first question, it's based on we have to do uh, here we have to do in first question we have to do conversion of binary to decimal, octal, and hexadecimal. So now I'll open my file and show you my code. So this is for binary conversion to decimal, octal, and to hexadecimal. So here what we are doing, we are just converting our uh, our binary number to we have to give input as 10 in 1 and zeros. So first here we are taking power of whatever, it's like if we are converting into decimal, so we have to take power of 2, and at whatever position is, that means if it's 1, so we have to take to the power 1, and if it's 0, to the power 0, means like that we have to take position, and then we have to add all those values, and that value will be our decimal form of that binary value. So here we are taking the remainder of that number, so that's why we are dividing it by 10. And then we are means first we are taking our power as 1, and then whatever remainder we are getting, we are multiplying with our power. So and then whatever means that power is, so that's our part of one answer, so we are adding with the a decimal value. So first there is nothing in my decimal, so it will take first number only, and then again my power value means it will multiplied by 0, means it will increase, and then the increased value will take up the position of this power, and that's how, and by dividing it by 10 it will move to second number. So that's the decimal conversion will be done. And now for binary to octal, so first from binary to octal we are converting into decimal, and from decimal we are converting into octal. So for decimal we are repeating the same procedure, but for decimal what we are doing, from decimal to octal we are dividing it by 8, whatever remainder we are getting, we are it means echoing it together one by one, and then for the next going to next value we are dividing it by 8. So that was for conversion of uh, uh, octal, binary to octal. And now we are doing it for hexa. So in hexadecimal, so its position means its numbering is 0 to 9 and A to F. So for 10 we will write A, for 11 if we are getting 11, so B, 12 C, 13 for 13 we for 13 we'll give a D, and 14 E, like that we are doing this. So first we are dividing in means first we are converting into decimal, and then again decimal value whatever we are getting, dividing it by 16, and then that number whatever remainder whatever remainder is, that we are taking A, B, C for that remainder. So that's for that we are using case, and then we are echoing together, and for going for next into next number we are dividing it by 16. So now I'm going to compile and show one value. So like I'm giving my binary value, some binary value. So here if you want to convert it to decimal, see it's in binary to decimal 11 position. You can see 11, it's 8 plus 4, 8 plus 2 10 plus 1 11. And if you want to see into some binary value in octal, like octal, so you are getting 12. So and now we are going to do conversion from decimal to binary and all this number. So here you can see here we are using the same thing what we did in the last thing. We are taking the number. Here you can see we are taking the number and then conversion, giving choices and all. And first we are dividing it by 2, because for binary we have to take the LCM of that number, and whatever remainder we are getting, that remainder will be our from bottom to top, where that remainder will be our binary value. So that's why we are echoing this thing, so that it will take from remainder to bottom to up. And then for octal value we are just dividing it by 8. And for the difference here is the 16. Here we are means in hexa, for hexadecimal we are dividing it by 16, and for 10 we are taking 11 and sorry a, and for 11 b, like that we have used if and else statement here. And then for going for the next number we are dividing it by 16. So now I'm gonna compile this. So um, so we have just 12 binary value. See here 8 plus 4 binary value 14. Yeah, so now my next is an octal to decimal. So here the same concept we are using. We are just converting our value to decimal, and then we are converting here. So we are taking octal number and then we are converting into decimal, like we are taking power of that number, whatever position is for that number, to the power 1, to the power 2, like that, and then we are adding it, and then that's how we are showing our decimal value. And then for binary we are doing the same thing. First we are converting into decimal, and then from decimal to binary. So whatever we did for binary we are doing the same thing, dividing by 2. For hexadecimal we'll divide it by 16. Here you can see first we are dividing to decimal and then we are dividing into c yeah, 6 divided by 16, so that we can convert it into a hexadecimal. So now I'm gonna compile it. Yeah, and entering any number. So for decimal that's what we are getting, and then 2 into yeah, so see you can see 1 and 0. So now my hexa, from hexa, so in from hexa to octal and all conversion. So this is a very like here we are only using the syntax. So by using syntax we are converting our hexadecimal value to decimal, binary and octal and all. So first we are taking here for, so if you want to convert directly, we're taking hexadecimal value, want to convert it directly, we will just take our I base and then our number, and that value will be our hexadecimal value. But for if we are converting into binary, so we are taking means we are converting that hexadecimal value into binary. So for that we are taking our base as 2, and for octal we are taking our base as 2, so that after that what we are getting is hexadecimal value of that binary value for our hexadecimal number. So this is, save it, and so first I want to do decimal conversion, so I'm giving any hexadecimal number. So here you can see 18. So yeah, any 12. Yeah, you can see it will take the 4 first 4, and then that value means 2, so it's taking 4 of that 1 0, that position 0 0, and then for 1 again 1, so it's starting with 1, so that's why my 1 position is like this. So this was my fourth Unix and Linux lab experiment. Thank you.